am going to be covering 4.1, which is our Hindu-Arabic system and early positional systems. To start off the section, I listed some vocabulary that you need to know just so you have an overall view of what's coming in this section and so you understand what is going to be going on. The first part of this section is exponential notation. If you'll take a look, it is the definition of a natural number exponent. So if b is a real number and n is a natural number, then it would be b to the nth power, which is how you read that. So whatever n is, you'll multiply b that many times. So there's an example on the next slide. If you'll just take a look, b to the first power, of course, equals b. Here are some examples of that. 2 to the third power, so 2 would be b and 3 would be n. So basically you just do 2 times 2 times 2 3 times because n equals 3, and that equals 8, and so on. We'll skip down to 10 to the third power. You would just do 10 times 10 times 10, and that equals 1,000, and so on. And this is just an example of that. The next part of this section is expanded form. With the use of exponents, Hindu-Arabic numerals can be written in expanded form, in which the value of the digit in each position is made clear. In a Hindu-Arabic numeral, the place value of the first digit on the right is 1. The place value of the second digit from the right is 10. The place value of the third digit from the right is 100, which is also 10 squared. So in this example, we can write it as 3 1,000s, 4 100s, and there's 0 10s, and there's 7 1s. So you just expanding everything out, and then at the bottom of the page, they do they're going from expanded back to the original when everything's back together. So you can do it both ways, and they're reversible. So with the Babylonian numeration system, rather than using the power of 10 like we do, this system relies on the power of 60. And instead of using the numbers 0 through 9, they just use the down symbol, which equals 1, and an arrow pointing to the left, which equals 10. So if you'll take a look at the example, we're given a down arrow, 1 pointing to the left, and 2 more down arrows. So we start with the one furthest to the left, and instead of it being 10 squared, like in hours, it's 60 squared. So you do 1 because the down arrow is 1 times 60 squared plus the left arrow is 10, so you do 10 times 60 to the first, which is just 60, and then you add that one to the 2 pointing down arrows, which just equals 2. And then you have to have your ones place, your so-called ones place, which is just 1. And then you just solve all of that out, and you get 4,202 is what all those arrows equal. The final portion of this section is the Mayan numeration system. This system was actually the first to have a symbol for 0. The table is pretty much self-explanatory. Each dot equals 1, and each line equals 5. And the symbol for 0 kind of looks like a basket. So this one is different from the other two that we looked at. They write their numerals vertically, so that's how you have to write everything out, which makes it easier kind of when you're adding everything at the end. So the place values are at the top, 18 times 20 to the third, and then it goes down to 18 times 20 squared, and then it goes down to 18 times 20, and then you have the 20th place, and then you have the ones place. So in this example, it only goes up to 20 squared, 18 times 20 squared. So take a look at the first numeral. There's 4 dots and 2 lines. So that's going to be 10 plus 4, which is 14. And you're going to multiply that by 18 times 20 squared. And you'll multiply everything out. Then you look at the next numeral, and that just equals 0 times 18 times 20 to the first, which is just 20. So multiply all that out, you get 0. Let's look at the next numeral. You have 2 dots in a line, so that's 5 plus the 2 dots, which is 7. And then you just multiply that by 20. You get 140. And then we'll look at the next one. You got 2 dots and 2 lines, so 5 plus 5 is 10, plus 2 is 12, and that's just in the ones place, so you just multiply it by 1, and then add everything up and you get your answer.